What's up, people? Hey, we're on pages 47 and 48. So we're going to be doing our 2-5 additional practice. That's what's behind me here on the big board, okay? So, hey, let's hop right into it. So, again, we're finding unit rates, okay, through different methods, graphs, equations, tables, whatever they give us, we got to figure it out, okay? Y divided by X is your best friend. Remember it, write it down, figure it out, okay? Here we go. We're buying jeans. It says find the unit rate for Jenny's Jean Store. So I look over here on the graph for Jenny's Jean Store. Again, our favorite point to use on a graph, that's proportional, of course. Guys, and this one goes through the origin. It's a straight line. I want this point right here, right? This is that 1 comma R that I know all of you remember from 7th grade, right? This tells me, hey, this is your unit rate per one pair of jeans, okay? Let's say you didn't. Guys, this is still the ordered pair 1 comma 20. Here's an X value, here's a Y value. Y divided by X, okay? So Y is the cost, X is the number of pairs. 20 over 1, 20 divided by 1, bam, $20 per pair of jeans. Now look, folks, you could have used this point. You could have also used this one here, even this one up here. It doesn't matter. The ordered pair will change, but what will not change, $20 a pair. It says find a unit rate for Jean Warehouse. We are going to do the same thing, folks, Y divided by X. So pairs of jeans is an X, right? Cost is a Y. You pick out any one of those you want to. Smaller numbers are typically more better for us, so I'm going to pick out.
Better.
Yeah, I'm going to pick out 2 comma 36, right? So 2 comma 36. 36 was the cost. 2 is the number of pairs. I'm going to do some mental math in my head. $18 a pair. All right. So so blank charges the higher rate? Well, that would be Jenny's Jean Store. Jenny and her jean store charges $2 more per pair of jeans. See how good I was there? They didn't even ask that question.
Wow.
Woo. Okay.
This guy is on fire.
That's right. Question 2. The graph shows the average speed of car number 1. Car number 1 right here. The equation y equals 55x represents the average speed of car number 2. Okay. So guys, car 2 is y equals 55x. Can you correctly identify the unit rate, also known as the constant of proportionality, from an equation? Hopefully you're all shaking your heads along with me. Yes. People.
Coefficient.
It is just, oh man, it is an 8th grade word, the coefficient. That's the number in front of or before a variable. So guys, car number 2 has a unit rate, right, of 55. Okay? So we need to compare that to the car 1 that we see on the graph here. Again, does this one go through some nice points? Yes, it does. This happens to be the ordered pair 1 comma 64. Y divided by X. Why do we do that? So we can get the right unit rate. And in this case, we take 64, we divide it by 1. We still get 64. Now we can answer which car is traveling at the greater speed. That's right, it's car number 1. 64 miles an hour versus 55. All right, pop over here, guys. We're almost halfway done with this. This is great.
It don't take long.
The graph shows the proportional relationship between, here we go, number of workers and weekly cost for a company in its first year, okay? The following year, the company spends $7,200 per employee, $7,200 per 12 employees. Did the rate increase or decrease? Okay. Well, so this is the second year, guys, right here, $7,200 per 12 employees. So I need a unit rate. So I don't want per 12 employees, I want per 1 employee, okay? So it was $7,200 for 12. What is that per 1 employee? Okay, so I got to do a little bit of math here. I'm going to say that's $600, right, per employee. I took 7,200, divided it by 12. Okay, we need to compare that to the first year. Here's their expenses. So again, we need to pick a good ordered pair, folks. I'm gonna say this one right here is a great ordered pair.
That's a good one.
Could pick that one right there. Let's pick this one right in the middle here. This is 10, comma. Oh, Mr. No, I need help. I need a number that's halfway between 5,000 and 10,000.
Huh. Well, what's halfway between 50 and 100?
I don't know. How about 7,500?
Good one.
Yes. It just came to me, folks. It just came to me. Okay.
This guy's good.
All right. So, again, so this means, guys, that the company spent $7,500 for 10 employees. How much are they spending per one? I don't know, but what I do know is that we can do the same thing. 7,500 for, nope, not 12 employees, 10, right? This should turn into $750. So in year one, we were 750. In year two, we went to 600. So did the rate increase or decrease? Did it go up or did it go down? Well, it was 750. It went down to 700. So we would say it decreased, and they didn't ask it, but it decreased by $150. Okay. Good news. We are halfway through key concepts. I know.
No, the additional practice.
Whatever. Additional practice. Who's to say? Here we go. We're talking about plants on number 4. It says which plant grows at a faster rate. Okay. This is in a table for plant 1. I don't care which ordered pair you choose.
Doesn't matter.
You pick whichever numbers you think you can divide in your head. Oh, hey, I'm good at 5s. I want to do that one. Okay. Guys, this is the ordered pair. 5, comma, 20. So y divided by x. Y divided by x says 20 divided by 5, which says, hey, for plant number 1, it grows 4 inches per week.
4 inches?
4 inches per week. Okay? How about plant 2? Ooh, this one's on a graph. Guess what, folks? Pick out any. Look at there are good points everywhere.
All over.
I can go here. I can go here. I can go here. Anywhere you want to.
There's
Okay?
a lot of them.
Yeah.
Wow.
I'm going to go with this one right here. So this is 8, comma 16. Again, here's my x, here's my y. Y divided by x. Why? Because we'll get the unit rate. 16 over 8. This one is 2 inches per week. Okay? So which plant grows at a faster rate? Definitely plant number 1. Okay? Alrighty. Alright, we're filling up a pool here. It says the relationship between the time and hours to fill a pool is proportional. Okay. After 4 hours, the pool holds 5,200 gallons of water. After 4 hours. Not after 1 hour, but after 4. How could you graph it? Well, guys, we would literally say it's proportional. So it does 2 things. It goes through the origin, right? And it is a straight line. And I know at 4 hours, right, it is at this 5,200, right, mark. Okay? Now, you think we can figure out a unit rate for that one? We might as well go ahead and do that. Okay? I know they didn't ask for it yet. Okay? If we were going to figure out a unit rate here, right, gallons per hour, right? It's just like 7th grade. Take the gallon number, divide it by the hour number. That's all we got to do.
That's it.
5,200 divided by 4, guys. Let's see. That's 1. That's 12. That's 1,300 gallons per hour. Okay. Now, part B, right, says, hey, they filled up another pool. Was the second pool filled at a faster or slower rate than the first? The first one was 1,300 gallons per hour. This one, man, we got all kinds of good dots, but I don't know what any of these numbers are. So, guys, why don't we just use this point right here? This is 3 hours, 10,800 gallons. Okay? All right, well, let's see. Same thing we've been doing. Y divided by X. Gallons divided by hours, guys. If we take gallons, 10,800, and we divide that by 3. Whoa, whoa.
Hey now.
Oh no, marker down. So guys, yeah, we can do this here. I tried to break Mr. Knoll's marker. It's all bad.
I got the answer. Since you've been, it's 3,600.
3,000. I think we're, yeah, there we go. 3,600. All right, that's our gallons per hour. Okay, so was it filled at a faster or a slower rate? Well, guys, clearly the second pool was filled at a faster rate. Okay,
Clearly.
almost 3 times as fast. I mean, these numbers weren't even close, right? In 3 hours, they put in this much. In 4 hours, we didn't even put in a number bigger than this one. So how could that possibly even be right? How is that supposed to be a higher order thinking question?
I don't know.
I don't know either, but it didn't take us that much brain power. Good thing, because I got a little bit left for question 6. The graph shows the relationship between the time in minutes and the number of milk cartons that machine 1 can fill. Okay? So again, that's the graph, machine 1. The equation describes the rate in which machine 2 can fill cartons. So once again, folks, this is machine 2, right? We identify the unit rate, the constant of proportionality, right? It is 22, right? So this means it fills 22 cartons every 1 minute. What is the unit rate for each machine? Okay, so here we go. So we have machine 2
Machine.
is 22.
I used the word superior dairy. Does that?
Yeah, did Mr. Knoll tell you the story about Superior Dairy?
Ooh, I learned a lot in life at that place.
Yes. Okay. Well, we can talk about that later. For now, we're going to figure out.
Ask me about it.
Yeah, ask me about it. I like this point right here.
Good point.
2, comma 50. Y divided by X. Right? 50 divided by 2. What is that, guys?
25.
25 per minute. Right? So again, this is how many cartons each machine can fill.
Machine.
So what is the unit rate for each one? Who did that? Which machine can fill cartons at a faster rate? That would be machine 1, guys. So this is machine 1. And then it says how much faster?
Oh
well,
my.
it does 3. 3 per minute, right?
I thought that was 4.
No, Mr. Knoll. 25 minus 22 is 3. Okay? So there you go, folks. So that was our additional practice. We should be able to move in now to our quizzes, bookwork, math, Excel. Have a great day.